Hello, this is Joshua, and this is a report about 802.11 family of Wi-Fi standards. We're going to discuss about the history, functions, and security aspects. The most important thing is we have to ask why that the standard has evolved on coverage, capacity, speed, and security. First, we will start with the historical backgrounds of the standards. In 1985, the US Federal Communications Commission released with rules for unlicensed use of 802.11 technologies. In 1990, the IEEE, also called as the Institute of Electrical and Electronics Engineers, has begun to establish a standard for WLANs. In 1991, Nokia Labs and LSI Corporation, which were called the NCR Corporation AT&T those days, intended to use the technology for cashier systems. In 1997, a final draft of the 802.11 was approved. In 1999, the 802.11a and 802.11b standard was approved. The 802.11a carries more data at 54 megabytes per second with lesser interference but has a smaller coverage compared to the 802.11b. The 802.11b is used for regular Bluetooth devices, cordless portable phones, some microwave ovens, and is very popular because of its low price. In 2003, the 802.11g standard was approved. The objective is to accept the standard of 802.11b wireless network adapters. It is a combination of both 802.11a and 802.11b. In 2009, the 802.11n standard was approved, and the 802.11n has four major improvements. Number one, that is the speed, carries up to 600 megabytes per second. It has a very strong big coverage, twice the indoor range with triple outdoor range. Number three, it has a strong interference resistance. Number four, it has a stronger security than the previous version. In 2013, the 802.11ad standard was established, which is designed to replace the fiber optics and many times faster than the previous 802.11n, but it has a very low indoor range of only 10 meters. In 2014, 802.11ac was approved. This standard is labeled into two phases, Wave 1 and Wave 2. Wave 2 was only introduced in 2016, but it came with a 5 GHz with a wide bandwidth of 160 MHz and 4 spatial streaming capabilities. This is a standard that carries a higher bandwidth and capacity than the Wave 1. This is a table showing the improvement and the definitions of the standards from 1997 to 2014. As we can see, the frequency of 2.4 GHz in the first 1997 802.11, and we finally arrived at the 5 GHz in 1999, and you can see a vast range of the maximum data rate in 2014 at 7.2 gigabytes per second. The second part, we're going to talk about the functional aspects of the standards from 2016 to present. The 802.11ac standards, which is also called the Wi-Fi 5, has the extended channel binding with an option of 160 MHz and mandatory 80 MHz channel bandwidth for stations. It has more MIMO spatial frames. It has downlink multi-users MIMO with multiple SDAs. It has modulation capability of 256 QAM. It has beam forming with standardized sounding and response for compatibility between vendors compared to non-standard in 802.11n. It has easy MAC modification supports and is compatible for 20, 40, 80 and 160 MHz channels and the 802.11a and n devices. 802.11ay, it allows at least one mode of operation capable of supporting a maximum of at least 20 gigabytes per second and preserving the power efficiency per station. The 802.11ba changes to the both IEEE 802.11 physical layer and the medium access control, that is a MAC control sublayer for wake-up radio operation. The 802.11ax standards is an improvement for high efficiency WLAN physical layer and MAC sublayer for high efficiency setup in frequency bands between 1 GHz and 7.125 GHz. The 802.11az standards. This is an improvement for placing changes to both the 802.11 physical layer and MAC control that enable better accuracy with respect to defined timing measurement protocol executing on the same PHY type by reducing existing wireless use and power usage. The 802.11bb standards will define MAC control and several physical layer specifications for wireless connectivity for fixed, portable, and mobile stations locally. 802.11bd is an enhancement for the next generation version 2 standard to define 1 medium access MAC and several physical layer for wireless connectivity for fixed, portable, and mobile phones stations locally. 802.11be, this amendment defines the enhancement for extremely high throughout standard modification to the both standard 802.11 physical layers and MAC control, supporting a maximum output of at least 30 gigabits per second and a frequency operation between 1 and 7.25 gigahertz. Next, we're going to talk about the security aspects of the standards. This illustration shows the vulnerable Wi-Fi network blur edge. We should be protecting against row access points and evil twins. The WPA and the WPA2 are the mainly security solutions that we can use to protect our network. WPA addresses both encryption and authentication using TKIP. WPA2 is Advanced Encryption Standard AES using counter mode with chipper blocks chaining message authentication code protocol CCMP, which is completely different from TKIP. It is approved by the US government for top secret encryption. The conclusion is the 802.11 standards has changes according to the improvements since the 1980s. It defines progress in coverage, speed, capacity, and security. The wireless security environment has improved through WPA2, and more advanced 802.11 standards are pending for approvals. Thank you very much for your time and listening to this report.